A persistent challenge in education is the gap between what students can do in the classroom and what they can apply once the context changes. The ability to apply knowledge previously learned to a new situation is what we refer to as transfer of knowledge. Students' ability to transfer what they have learned is a problem that exists in my STEM classroom. They can demonstrate the idea in one situation, but when the context shifts, their learning does not always shift with it. This problem prompted my research question: how can educators design learning experiences that promote transfer of knowledge? Applying knowledge to different contexts and tasks has been studied for more than a century, but only in the last few decades has the topic been more thoroughly reviewed. Researchers Perkins and Solomons coined the concepts of near transfer, transferring concepts to similar tasks, and far transfer, transferring concepts to unfamiliar ones. Other studies have shown that transfer is not automatic. Students need time, guidance, and intentional strategies to make transfer possible. To answer my research question, I searched the ERIC database for empirical studies from the last 10 years that focus primarily on a middle school setting and specifically address transfer. I excluded studies about adult transfer. The 10 studies used could be divided into three key themes that answered the question of how teachers can create learning experiences that promote transfer of knowledge. First was hands-on and design-based learning. Across these studies, students who engaged in building, modeling, and testing and creating were more likely to transfer concepts to new situations. These tasks required active use of knowledge, encouraged revision, prompted students to make meaningful connections between what they were learning and the challenges they were encountering. These learning experiences provided repeated opportunities for students to apply concepts flexibly, supporting both near and far transfer. The second was instructional support. This research demonstrated that transfer improved when teachers used strategies that guided and structured students' thinking. Scaffolding, modeling, strategic questioning, and design thinking routines helped learners recognize relationships between ideas and understanding underlying principles. These supports strengthened near transfer by helping students see parallels across tasks, and they supported far transfer by equipping students with strategies that could be applied independently when the context changed. Over time, students relied less on direct guidance, indicating growth in independently applying this knowledge. Finally, the last theme was learning environments. Transfer was stronger in classrooms that encouraged curiosity, exploration, and conceptual organization environments that had introduced deliberate uncertainty were particularly effective in promoting far transfer. And students who developed coherent knowledge networks were consistently more successful in applying knowledge beyond the original learning conditions. The literature in this review shows that deliberate instruction strategies can increase the likelihood of transfer. However, there were limitations. These studies measured transfer differently. Some had small or narrow samples, and most focused on STEM classrooms. Even so, the overall patterns were consistent across the literature. Both near and far transfer can be strengthened through intentional design.